Hello again. This video is all about expectation values. Right, expectation values. So what is an expectation value? Well, an expectation value of a specific event is what you expect it to be out of intuition. For example, if you have a coin and you would toss it 6 times, how many heads do you expect to come out? Well, I think you expect to see 3 heads, right? I mean, that makes sense. You toss a coin 6 times, since the probability of getting a head is 50%, then in 6 times you logically expect it to land 3 heads and to land 2 tails. Alright, so let us see if we can mathematically show that it is going to be that way. So let us try it out. First, for us to get the expectation value, so it would be called the expectation value of a random variable x. The expectation value of a random variable x is equal to the sum of I from 1 to n of the particular event xi times its probability. Alright, so what it means is, if you're going to toss a coin 6 times, then each of our events is getting 0 heads, so we'll call event 1 as getting 0 heads, event 2 as 1 head, event 3 as 2 heads, event 4 as 3 heads, event 5 as 4 heads, event 6 as 5 heads, and of course event n, or in our case event 7, is going to be 6 heads. And so the next step for us is to to calculate, the probability of each of those events. So let's go down for a bit. How do we calculate for P1? Or basically, that's equal to the probability of getting 0 heads. We understand that this thing is a binary distribution, since there's only 2 choices, a head or a tail. And so we know that it would be n choose k times the probability of getting success, p raised to k, times the probability of getting the failure, which is 1 minus p raised to n minus k. Alright, in this case, the number of successes is 0, because success, we define it to be heads, k is equal to 0, and as you can see that n is the number of tosses. This should be n plus 1. Since we start at 1, we should have started 0. So we can actually translate this into I from 0 to n. Yeah, that makes more sense, right? But if we're going to consider this thing that we built, the reason that it goes until 7 is we should put from 1 n plus 1. Alright, so let's talk about k0. So that's as easy as the 6 tosses, so that's 6 taken 0. P is 1/2, of course, 50% chance of getting ahead. The number of successes is 0. And 1 minus p, of course, is 1 minus 1/2 is 1/2, and that's n minus 0, and n is 6, so that's 6 minus 0. So this 6 choose 0 is equivalent to 6 factorial over 0 factorial times 6 minus 0 factorial. And 1/2 raised to 0 is 1, and 1/2 raised to 6 is 1 over 64. So let's just write it down like that. And what is this 6 factorial over that? That's just equivalent to 1, isn't it? And so we're left to 1 over 2 raised to 6, which is equal to 1 over 64. Alright, that's quite nice. Let's go down. So how about when we do the probability of getting 1 head? Well, that would be 6 tosses, 6 factorial, over choose k, 1 factorial, times 6 minus 1 factorial. The probability 1/2. Now k is equal to 1, so it's raised to 1, and still 1/2. And now we have 6 minus 1. So let's see what this thing is equal to. Alright, so we have a 6 factorial divided by a 5 factorial, right? So we will, in this case, we'll be left with 6 times 5 times 4 divided by 5 times 4, blah blah blah. So that thing cancels out, leaving us with 6, and 1/2 raised to 1 is 1/2, and that is times 1/2 raised to 5. But 1/2 raised to 5 is 1/32 times 1/2, and that thing is just the same thing as 1/64, same thing as the answer previously, but the only difference now is this has a 6 in front, so it's 6 times 1/64. Alright, as I mentioned to you last time, the coefficients in front of the binomial distribution is a reflection or the same thing as the numbers that we can find from the Pascal's triangle. So if we would construct our Pascal's triangle, we don't really need to go and compute for all of this. All we know is it's going to be a number. For example, in this case, it's 1 times 1/64. The next number is 6 times 1/64. So what we can do is figure out what this coefficient is using the Pascal's triangle. Alright, let's try construct one. We have 1, 1, 1, 1, 2, 1. Then we have a 1, 3, 3, 1. Then we have a 1, 4, 6, 4, 1. Then we have a 1, 5, 10, 10, 5, 1. How do we know when to stop? Well, there is actually a relationship between the number of torsos, or the n, to the level of the Pascal's triangle. This corresponds to n. Let me change the color. This corresponds to n equals to 5. This corresponds to n equal to 4. This corresponds to n equal to 3. This corresponds to n is equal to 2. This corresponds to n is equal to 1, which makes sense, right? And this corresponds to n equal to 0. So of course we start at 0 where you don't choose anything, then you choose something. So it all makes sense that you have 0 torsos, 1 torso starting from the top of the Pascal. So what we need is n is equal to 6, which is obviously at the very bottom of this. So you start at 1, then you notice the answer is 6, which is exactly the same as what we have there. And then we have 15, then 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then write the 1 in there. So this just shows to us that we would have coefficient of 1, 6, 15, 20, 15, 6, and 1 in front of 1/64. So if we collect all of that, we would have 1, 2, 3, 4, 5, 6, 7, which is exactly how many events we have. If we try and go back to our previous case, you see that we have 1, 2, 3, 4, 5, 6, 7 events, which corresponds to this coefficients right there. So if you see now, we can construct without doing all of this, without doing all of the computations. We understand that what we have using the Pascal's triangle is 1 times, then we have a 6, and then we have a 15, and then we have a 20, and then we have a 15, alright, and then a 1, alright, and all of that is multiplied to 1/64. 64, 1/64, and finally 1/64. And this corresponds to 0 heads, 1 head, 2 heads, 3 heads, 4 heads, 5 heads, and finally 6 heads. 6 heads and 6 torsos. Alright, so now we have the probabilities, and this thing actually corresponds to, in our case, P1, then P2, then that's P3, then P4, that was P5, P6, and P7. And if you remember, what we had was the sum of the xi, which we define as the event, and these are the events times pi, which is right here. These are all the PIs from 1 to n. And in that case, our n here is, n plus 1. So it's I from 1 to n. Alright, let us see. That is the definition of the expectation value. So a while ago we said that if we toss 6 times, we expect it to land 3 heads. So would a mathematical analysis bring us to the same conclusion. Alright, let us try it out. Let's see what we get. So what would this be? So we have the event of 0 heads multiplied to this thing, which is 1 over 64. Summation, right? Summation. So we need to add it. Plus getting 1 head times it's now 6 over 64. Plus getting 2 heads and now it's 15 over 64. Plus getting 3 heads and it's now 20 over 64. Plus getting 4 heads and we go back to 15 over 64. Plus getting 5 heads and now it's 6 over 64. And getting 6 heads, there you go, and 1 over 64. I hope we can add all of this together. But in our case and purposes, let me grab Excel. So I had grabbed Excel right here, and let's try and solve this using Excel. So what we have is a 0 times 1 over 64. I know I should have not written that, type that, but just for the sake of clarity, I am going to just type everything according to this. So it's now 1 times 6 over 64, alright, parentheses, plus 2 times 15 over 64, plus we have 3 times 15 over 64, plus 5 times, oops, I'm sorry, I forgot my parentheses. There should be a parentheses right there. 5 times 6 over 64, close parentheses, plus 5 times 6. Oops, I missed 4. Alright, sorry. It should be 4 times 15 over 64. And then we have parentheses 5 times 6 over 64. And finally, almost there, parentheses 6 times 1 over 64. Just close parentheses. Alright, hope it works. There we go. Press enter. 2.76. Alright, I think there's something wrong with my formula. Let's take a look. Oh, I see that. It should have been 2 times 15 and this should be 3 times 20, right? Yeah, 3 times 20, as you can see. There we go. 20 right there. Let's bring back Excel. Alright, so let's press enter again. Oh, there we go. What do you get? 3. So this entire thing is equal to 3. So it means that the answer to this, the expectation value, is 3, which is what we expect to be. In 6 tosses of a coin, we expect to get 3 heads. There we go. So it means that the expectation value is naturally what we expect in intuition. Alright, in the next video we are going to see the very definition of the expectation value, which is equal to the sum of let's just change it to, let's adjust it by 1, so start at 0, and of xi times the pi is just the same thing as your average. Alright, so what we will do is say that the expectation value is just the same thing as the average. So we will mathematically see how that happens, but if it does, then that's a new definition for you guys. Expectation value is the average. Alright, thanks for watching. See you again next time.